Hello everyone, I'm Shubhayan Sahu. I'm a PhD student at the University of Maryland, and today I'm going to show you an experiment about pendula with 4:1 length ratios. So what we have here in this apparatus are two different pendula with the same bobs. The bobs are of the same mass, but one pendulum is 4 times, the length of the string of one pendulum is 4 times that of the other. And because the mass of the bob is much larger than or heavier than the mass of the string, so we can imagine that the effective masses of the two pendula are roughly the same. So what we're going to do in this experiment is that I'm going to release these two pendula at the same time, and what we have to answer is what are the time periods of this pendula going to be. Are these two pendula going to oscillate with the same period? Will the shorter one have a longer period, or will the shorter one have a shorter period than the longer one? So let's get started. Just to reiterate, we have two different pendula with the same effective mass, but one is 4 times as long as the other, and I'm going to release them at the same time. So pay attention to what happens to the periods of the two pendula. So was your prediction correct? As you can see, that the longer pendula has a longer time period than the shorter pendula. The shorter pendula is clearly oscillating much faster than the longer one. And if you pay close attention, you will actually be able to see that the time period of the shorter one is half as much as the time period of the longer one. And that is directly related to the equation that you would learn about the time periods of the pendula, that they are proportional to the square root of the length. That means that the longer pendula, which has 4 times the length of the shorter one, will have a time period which is 2 times the time period of the shorter one, which is square root of 4. So this experiment demonstrates that very simply. And yeah, thank you for paying attention.